So next topic is data hazards. So usually we see the data path will flow from left to right, but in the write back stages, it will paste its result back into the register file, which is in the middle of the data path. So the path now it will flow from right to left. So this will lead to a data hazards. In other words, I can tell it will occurs in the pipeline process when the next instruction needs data, but it is not ready yet. So this will lead to a data hazards. What are the types of the data hazards? Is first one is RAW. So it is called as read after write. It's also called as data dependency. So it occurs when the instruction reads a register before a previous instruction write to it. So you can see here, this is nothing but this is the first instruction, this is the second instruction. In the first instruction, add R1. So R1 value is equal to R2 plus R3. So if it is 2 plus 3, so the 5 get written writes into R1. In the second instruction, it is nothing but R4 is equal to R1 minus R. So now it has to be 5 minus since it is 5, 5 minus let me assume this is 4. Okay. But before writing the data into the R1, suppose if the instruction 2 reads the data from the R1, means it will causes this hazard, data hazards. Okay. So you can see. So it will occur when the instruction 2 try to read the data from the register R1 before the previous instruction write the data into the R. Okay. So how to avoid it? So with the help of operation forwarding, we can avoid it. Okay. So you can see this is IMR register, ALU, DM and the register. This is another name for instruction fetch, instruction decode, instruction execution, memory access and write back. Okay. So for the first instruction, that is add R1, R2, R3. So what will happen is the IM stage will executed and this register stage get read it, right? So whenever there is a like this type of signal, it is called as read. Okay. So I have readed the data from the this instruction decoder. Okay. So after that the ALU will perform. So you can see for add instruction we don't require the memory access. So it is a skipping the stage, and this one is called as pipeline register. Okay. This one is called as pipeline register because this register is used to handle the data between this two stages. Okay. So suppose whatever the instruction that gets stored in the pipeline register. Okay. So for that one it will get used. So after that it will get added and it will be right into this register. So if there is a dash mark at the left hand side, means it's called as write. Okay. Okay. So only after this stage only you will get the value of R1. Okay. So if I start it from here, this data will be available during this stage. So during this stage, the subtraction will perform this operation, right? So during this stage, during this stage itself, it will read the data from R1 and R5. Okay, it will read the data from R1 and R5, but the instruction 1 will will be over only during this cycle. Okay. So we have to use either operation forwarding method. So operand forwarding method. What is operand? This is called as operand. Okay, this is an operand. These three are operand. So you can see the add will perform at this instruction execution stage, and the data will be stored in the in this register. So the R1 value gets stored in this register. So now I'm going to forward to this one to the next stage. So So I'm forwarding it to the next stage. So that I don't want to wait up to the stage to complete. So by using this method, operand forwarding method, I can read the correct data of R1. Okay. Here I am going to discuss the data hazard using load use data. It is also called as load use data hazards. So this load use data hazards is avoided by using a pipeline installer bubble. So what is load use data hazard means? Here the I'm using the load instruction. So here the data being loaded by the load instruction has it available when it is needed by the another instruction, that is sub T3 S1 comma S2. So here you can see I'm going to load the value of this one into S1. So this will happen only at this stage. Okay. So it is going to write the data of S1 into only at this stage. But without using the pipeline stall, so the subtraction will start here, right? So it will be IM ID, right? IM ID and IE. So during this stage, the subtraction of it is on this stage, the data is not loaded. Okay, the first instruction data is not loaded to the S1. So this will, so therefore it will cause us a hazard. So I'm going to install a pipeline stall or bubble. So if I use the bubble means you can see. So between this one I am using a pipeline register, right? So I'm going to use a pipeline register. So from the memory only, the load instruction will load this data. So this the S1 data is available at this pipeline register. So I'm going to transfer that into this ALE, that is instruction execution. Okay. So by this way, I can avoid this load use data hazard. So another method to avoid this data hazard is with the help of PRA. So you can see this is a load word. So here the T naught data get stored inside this T1, and T naught data get in the next instruction, the this value gets stored in T2. Okay. So generally these two instructions will take more time compared to the add T1, T2. So before writing the data of T naught and this data into T1 and T2, add will try to read the data of T1 and T2. So this will lead to a data hazard. So what I'm going to do is, so instead of writing this instruction, what I'm going to do, um, I'm going to rearrange this one. So I'm going to copy this, okay, and I'm going to paste it here, this load data. So by this way, you can see. So now if the add instruction try to read the data from T2, that this data from the T naught get already written into right into T1 and T2. So it will have an enough time. So therefore the hazard get completely eliminated. Okay, by rearranging the load instruction. Okay. So the next type of uh, data hazard is write after read. Okay. So this is my second type, with this anti-dependency. So consider first instruction is sub R4 comma R1 comma R2. So what it will do? This is it will do R4 is equal to R1 minus R, right? This is my first instruction, and the second instruction is add R1 comma R3 comma R5. So this is nothing but R1 is equal to R3 plus R4. So you can see uh, the R4 try to read the data from R1 minus R2, and it will be stored in R4, right? So this instruction reads the data from R1, and it will be stored in the R4. What the add instruction doing, it will write the data into R1, right? So what will happen if the write if the second instruction execute first? So it will write the data into R1 before instruction 1 reads the read R1 reads R1. So this will causes an hazard. This type of hazard is called as write after read. Okay. So it will occur only. It will not occur in the pipeline uh, stages, that is MIPS instruction. So it will occurs only in the architecture with out of order execution. Okay, so this is my second one. The third one is write after read. Yes, sir. So you can see the first instruction. The first instruction is this is called as output dependency. So here the first instruction is multiplication of R2, R3, R4, and second instruction is add R2, R5, R6. So it will write the data into R2, right? So here also it is write data of R2. So this will occur when the I2 instruction executing first. Okay, I2 instruction writes data into R2 before I1 instruction writes data to R2. Okay, generally the multiplication instruction will take more time compared to the add instruction. So the I2 instruction, if it tries data into R2, so there will be a problem. So this is also due to the out of order execution. Okay, so final value of R2 must be the I2 instruction value only. But since the I1 is execution at last, so the processor may take the value of I1 instruction value of R2. Okay, so this will causes an write after write the data concern. So this can be avoided with the help of register rename. Okay. So instead of R2, if I use some other value, means I can eliminate this one.